In this practical video, we will discuss about protein C assay. So, what is protein C? Protein C and protein S, protein S and C, they are two vitamin K dependent plasma proteins that works as a natural anticoagulant. And then activated protein C is a proteolytic component of the complex, and then protein S serves as an activated protein C binding protein that is essential for assembly of anticoagulant complex on cell surfaces. Now if you look in this picture, we can see two scenarios. One is a balance and one is imbalance. So when procoagulants and anticoagulants are in balanced form, then clotting as well as bleeding takes place in a proper way, in a normal way. But when procoagulants and anticoagulants are imbalanced, if suppose procoagulants are more in number, then clotting, the load of the clotting is more and bleeding is lighter. So this test usually measures for anticoagulants, that is protein C. We will talk about protein C and protein S in a different video. So let's look into. So the principles that are involved in protein C assays are four types. First is the immunological, by the means of using an ELISA. But ELISA can only detect the amount but not the functional property. And secondly, we have a clot-based functional APTT, activated partial thromboplastin time. And then thirdly, we have chromogenic assay. And then fourthly, we have a thrombin generation based test. So let's go into one by one. First, we have the clot-based functional APTT. So the reagents that is used are, first we have platelet plasma, and then a surface activator that includes Kaolin, micronized silica or silite or ellagic acid, and phospholipid, for example like cephalin, and then a protein C activator, most commonly Protac, which is a snake venom, and then a calcium. So calcium is required in rare excess for coagulation to occur. So calcium is usually removed by chelation when clot is collected into a sodium citrate. So the methods involved: commercially kits that are readily available for protein C assays, and this should use a reference protein C standard calibrated against the current international standard for protein C that we will discuss later on. So first one is the protein C ELISA assay. And here most ELISA assays use either monoclonal or polyclonal antibodies against protein C. Now regardless of the protein C ELISA assay, we don't use much, so let's not discuss about the immunological section, but let's go into the other functional clotting-based protein C assays. So these are based on either the prothrombin time or the activated partial thromboplastin time. Here the patient's platelet poor plasma, or simply PPP, is incubated at 37 degrees Celsius with phospholipid, which is a contact activator, example Kaolin, and a protein C activator, example Protac, which is a snake venom. And after incubation for about 4 minutes, calcium is added to initiate clotting, and the time taken to form a clot is recorded. From this, the protein C level is determined from a reference curve. As I've mentioned earlier, we need an international standard curve. So this is one of the curves. So we have the clotting time here and the APC concentration. So in case of normal, we have a normal curve here. So it goes up, but with APC resistant, the curve doesn't go up, but it rather pulls down. So that is the curve. So patient platelet poor plasma is incubated at 37 degrees Celsius with the protein C activator, example Protac. After incubation, a chromogenic substrate for activated protein C is added, and the change in the optical density is measured, and by comparison against the standard reference curve, the protein C level can be determined. So now coming to the chromogenic protein C assays. This includes platelet poor plasma, the protein C activator, most commonly Protac, and then a chromogenic substrate that generates a color which is proportional to the concentration of the activated protein C. So you have to keep in mind that neither calcium phospholipid nor a coagulation activator is necessary, as the test plasma serves only as a source of protein C, and clot formation is unnecessary for this test. So the chromogenic assay is not influenced by the presence of lupus anticoagulant, and the factor VIII level or the presence of the Factor V Leiden mutation. So that is one basic thing that you have to keep in mind. Now coming to the interpretation, an activated partial thromboplastin time-based functional protein C assays can yield misleadingly lower levels of protein C in the presence of Factor V Leiden mutation and some other causes of APC resistance, elevated plasma factor VIII levels, and in the presence of hyperlipidemia. Now the chromogenic assay will detect low levels of protein C with high sensitivity and will detect most functional defects, but not all. For example, like an impaired phospholipid binding to a mutation in the GLA domain will not be detected, as the chromogenic assay is phospholipid independent, and an individual with a mutation in the GLA domain of the PROC gene will have normal chromogenic protein C assay, and similarly the chromogenic assay is not dependent upon the presence of protein S. Now coming to the reference range, the plasma concentration of protein C in a healthy baby is in the region of 40 international units per dl, and the levels increase with age and reach levels of 60 international units per dl, but may not reach true adult values until after puberty. Normal protein C levels in adults are in the region of 65 to 135 international units per dl. So as I've mentioned earlier in the curve here about the reference curve, so the levels are in order, are in normal form. So I hope you have understood with this protein C assay. Thank you.